All right, so today what we're going to do is we're going to continue our look at some lines, but today we're going to talk about something called the gradient. And you've probably heard the word gradient before, but you may know it by a different word. There are lots of different ways of saying gradient. So let's look at some of them. Because I never learned it as gradient. I learned it as slope.
Oh, yes, you had done.
Okay? But gradient, they use it in specific terms. Like if you're talking about a hill goes either up or what? Down, right? Then that's the gradient of the hill or the road they build on a hill or whatever. So slope or gradient simply means how much a line is going either up or down. So it just means how much the line goes up or down if any. Because are you always on a hill? No. Nope. You could also be flat, right? Okay? And there's also a case where it could be going straight up. So we're going to be talking about that as well. There are lots of ways of finding gradient or slope. And I don't care which word you use, but you need to be aware that the method you use is going to depend on the information that you're given. Okay? If I give you my email, can you call me? No. But can you still contact me? Yes. So it's like that. The specific information that you have is going to tell you what method to use. They're all interrelated, and the easiest one can only be used with very specific cases, and but the other ones can be used all the time, all right, or most of the time. There are three methods we're going to look at, and again, it depends on what type of information you're given. So we're going to look at three methods for finding. Do y'all mind if I call it slope?
No.
Okay.
I mean, I do.
You do? Slope/gradient. You're going to make me write that every time? Okay. All right.
Wait, so if you say one or the other, it just means the
Same thing. Slope, gradient means the same thing.
same.
Just like an exponent is also an index or a power, right? Same thing. Okay. Oh, baloney. You know what an exponent is. Okay. So, all right. Slope and gradient. So what I'm going to do is, the first part of it I'm going to put is the thing that you're going to see that will tell you how to do it. And then I'll talk to you about how to do it. So, first method. If you have the actual graph, in other words, they give you the picture of the graph so you can physically see the line. Okay? So you've got your graph with your x and y axis. You've got a line on it. Doesn't really even have to have it. It just can be on a grid, but they're going to give you a graph, right? So you can physically see a straight line somewhere. All right. If that's the case, then you're going to use counting. Okay. All you have to do is use counting. Now, I'm sorry. I need to put one more definition up here. Okay? When you're measuring, another way to say slope or you're measuring it is it's the rise over the run. Excellent. So you have heard all this before, right? Okay? Rise means how much it goes what? Up or what? Down. Run is how much it either goes to the left or the right. Yeah? Or right or left, whichever way you want to think about it. Okay? And remember that, so it's always rise over run. Well, that's backward from when we looked at a point yesterday. When we looked at coordinates, we always did right or left first and up or down second, right? But for slope or gradient, it's the other way around. So be careful. Okay. And the counting method takes advantage of the fact that you know that it's just how much it goes up versus how much it goes over, or down and right, or down and left, etc. So what we're going to do first is just choose any 2 points on the line. Now, it doesn't matter where they are, how far apart they are, how close together they are, one above the other. It doesn't matter. Any points. Because if it's a straight line, the slope is the same along the entire line. Okay? So you can choose points from where? Anywhere. So don't get caught up on, I have to pick these 2 points. Right? It doesn't matter what points you choose at all. Okay? The thing, though, is that they have to be on the line, and you have to be able to measure it easily. Okay? And I'll talk to you what I mean. So when you're choosing those 2 points that are on the line, remember our graph had all those little extra lines so we could count 1, 2, 3, 4, 5 over, right, and 4 up. Make sure that you only pick points that are intersecting those 2 little lines. And I'll show you plenty of examples where you can see what I'm talking about. Okay? So make sure that they are at intersections. That says intersect, but I'm running out of room. And I want to use the rest of the bottom of them. Okay? So it has to be where some of those smaller lines are crossing, though. Because otherwise you're not going to know how, you can't count the lines if they're not, if it's in the middle, you're not going to know what fraction that is, right? It has to be on one of the lines. Okay? All right. Then, simply count, rise, then run from one point to the other. And that's all there is to it. You're just going to be counting. Okay? So I'm going to show you that it doesn't matter where the points are. You don't even have to know anything else about the line by just doing a few of these on just blank grid paper. So there's not even going to be an X and a Y axis. We don't care. So all you have to do, I'm just going to draw a line and we're going to pick some points. Okay? Just to show you how generic this really is. So don't make it more difficult than it has to be. Right? So let's get some grid paper. Oops, that's pretty small, isn't it? There we go. All right. So I'm going to attempt to draw a straight line. All right. It's never a good thing. I wish I had a ruler. Here we go. Oh, hush. I hope it's a straight line. We'll see. All right. It's close enough. All right. I want to find the slope or gradient.
Do we have to draw this?
Well, you don't have the thing, but you could draw it. You could sketch it. But you're going to see plenty of these in your workbook too. Okay? Now, again, remember that's just rise over what? Run. Okay? So I can choose any 2 points as long as they're at the intersection of one of those 2 lines. Okay? So, could I choose a point right here?
Yes.
Look at where that is. Okay? Let me make it black so you can really see. Could I choose a point right here? Why not? Why wasn't that big a point? It's not where the lines are crossing, right? It's too difficult to see what that is. That's some fraction or decimal that I can't count from there easily, right? It may look like it's halfway between up the line, but you can't tell. How about if I chose that point right there? Is that okay?
Yes.
Yes, because it's right on one of where the 2 lines intersect. Get it? What I mean by picking things that intersect? So then all I have to do is just slide up here until I find the next place where they intersect. And that can be my second point.
Oh, I get it.
Do you get it? All right? So I just picked this point because it's on the intersection of 2 of those grid lines. Yeah. Mm-hmm.
Does it have to be like the exact next one? Or could it
No. Okay? So let's go. I don't know why that's not erasing, but okay. Let's pretend if my line was straight, that was... Okay. that was at the intersection. Could I pick this line, this point down there and that point up there? You bet. It can be anywhere on that line as long as it's where two of those lines cross. Okay? So we'll just do we'll do all three of these just to show you that it's the same. Well, assuming my line is straight, we'll see. I should have used my line. I have a line tool. What am I, crazy? I forgot. All right, I'll use it next time. So now all I'm going to do is count from the first point down here to the second point up here. Or I could call this one the first one and this is the second one. That just means to get from the first one to the second one, I have to go up and then to the what? To the right. Do you see? You've got to walk along straight lines. Anytime you're doing this, you have to follow the streets, right? Okay. Or I could go down and to the left. Doesn't matter which one you like to count. But down and left would mean you're working with what kind of numbers? Negatives. Do you like to work with negatives? No. Not usually. So up and right is usually your best option, right? Well, how many squares up did I go?
2.
1, 2, right? Do you see that? And then I went to the right. 1, 2, what? 3. So I went up 2 and to the right 3, which gives me a slope of 2 over 3. And that's all there is to it. Don't make it harder than it is. Now, the beauty of picking the next one, though, is this. It doesn't matter. Let's do it again, but let's do the... Oh, that's a lot of dots. That is, learn not to do that anymore, huh? Okay. Let's call that the first point and this one the second one. I want to show you that the numbers will still come out the same, but you have to do there's another step. Because to get from here, I have to go up to there, right? Oops, I'm sorry, I went too far. And then to the right, that way, right? Make sense? So that's up how many? 1, 2, 3, 4, 5, 6. So I went up 6. And then to the right, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. What's wrong with this fraction? It can be simplified. You can divide them both by 2, right? Just by 2, right? And, okay, so you know what that's telling me? My line's not straight. So it should have come out to be the same. What we got 2/3 while ago? Okay, it should have come out to be the same. My line's not straight. Let's look at some in the book where the lines are straight. But you get the idea. And anyway, just make sure, I just wanted to show you on here because I wanted to make sure that you're seeing that it has to be where this line's hitting those intersection points. That's what's important, okay? So it should have been the same. Now, when you're writing these, there is a notation for slope. And that notation is simply the letter M. If you see the letter M, and it's a lowercase m, if you see lowercase m, that always means slope or gradient. So when I ask you for the slope, you're either going to have to write out gradient equals, slope equals, or m equals. But you have to name it. You can't just put 2/3. Why not? Yeah, 2/3 of anything. I don't know what that 2/3 means. So you have to say it. So m is easier to do than write gradient, right? M is also going to be in your formula later for some of the others. So it's just easiest to use M to stand for slope. Okay? So let's look at then some from your book. Yes. You won't get an improper fraction from counting. Oh, you mean improper? Yes, I'm sorry. You won't get I was thinking you were going to mix numeral. I'm sorry. Yes, it's fine. Who cares? Your slope should be left as a fraction, so don't change it. Don't convert it to a mixed numeral. I'm sorry, I was thinking mixed numerals for some reason. All right, so here we go. Let's find your... Sorry, I'm having to scan these in because I don't have an electronic copy of your book. So here we go. Talk about the gradient of a line. The gradient, as we talked about, is the steepness or slope of a line, okay? And if you look at these lines, if you look at these first set of lines here, notice that they're all going up as you move, and you always look at it from left to right, just like you're reading a book, reading words on a page. And so these are all going up, which means that their gradients or slopes will be positive. So if you got a negative number answer there, you would be in trouble. Okay? Notice these, as you go from left to right, are all going down. That means the gradients are going to be negative. Okay? So you can always tell the sign of your slope by looking at which way the line is going as you're going from left to right. Because if you were looking at this way, that looks like it's going up. But is that the way we read it? Nope. We read it this way, from left to right. Okay? Just like you're reading on a page. All right. Now, the first thing they want you to see is that the steeper the line, the bigger the gradient, right? And more slope. So if you look at some of the examples they give you, this line is almost straight up and down, right? It's very steep. The slope of that is 4. But if you look at this one's leaning further over, isn't it? So it's not as steep a hill, right? And the gradient of that one is a 1. And this one's even further down. Gradient of that is 0.33. Higher number you're going to get. Exactly. Okay? So if it's very, very, very sharp, then you're going to get a higher number than if it's not quite as steep a hill. Okay? Don't worry about the calculation of using the formula there. We'll come back to it. Instead, I want you to see this thing. Rise over run. So you see they've done exactly what I did. They just drew a line, except they drew a straight line. And we're just going to use and since we have the picture, right? We actually have the physical graph in front of us, the physical line in front of us. We can use the counting method. So they just started counting here because that's at an intersection. And then they just went along the line until they got to the next place it intersects. And again, if you do that, if you make sure you pick the first place that intersects and the next one, then you don't usually have to reduce the fraction or simplify the fraction. It'll make it as small as it can be in the beginning. Now, that's no guarantee that you won't have to reduce the fraction, though, or simplify it. So let's count. Now, they went down, and then over. And why they say that that's 5 and that's 6, I will never know. What they did was they counted the run and then they counted the rise first. But really, count rise and run. And if you did it as rise and run, that should be what kind of 5?
Negative.
It's down, yeah, and that should be what kind of 6? Negative, because you're going left. But what they did was they did run and then they did rise. I don't like it, but what I would do is count up here and then to the right to keep everything positive. So look how many lines you have to go up. And you'll notice it's exactly the same numbers. 1, 2, 3, 4, 5 up. And then to the right, 1, 2, 3, 4, 5, 6. Okay? And you get the slope of 5 over 6. All right? So it's just a matter of counting. And again, why did they pick those particular points? Because it's where they were intersecting. Okay? And here, they did the same thing. I hate it. So they're counting from here to here. What they're doing is counting run and then rise. They're just counting in the positive direction and putting the right number in the right spot. But I would prefer that you just use the positive side. Okay? So 1, 2, 3, up. 1, 2, 3, 4, 5, 6, 7 to the left. Right? So make sure you put that negative because we went left. So negative 3 over 7 just makes the whole fraction negative. Because remember, a positive divided by a negative just makes the whole fraction negative.
So if one of the numbers is negative, you just put negative.
Then the whole fraction will be negative. But we knew the slope was going to be negative because it's going down, right? Okay? What if I ended up with something like this? A negative and another. Yes, a negative divided by another negative would make it positive 5 over 6. So don't forget your signs. But you could also tell, you also knew this one was going to be positive because it's sloping what? Up. So it's going up to the right, yeah. Okay? This one's going down as you go right. That's going to be a negative. Okay? So let's look at a few where we're just going to count out the slope. Too easy. Couldn't be much easier, eh? Well, they can do special cases next. Oh, well. We can do special cases. Sure we can. Oh, they're easy. Yeah. There are two... Oops. There are two special cases, and I already mentioned one of them. Notice this line. Does it go up or down any? No. Okay. So if there's no slope, in other words, a horizontal line, can you give me an example of a horizontal line using what we learned yesterday? Well, think about it. One of the axes is horizontal, isn't it? The x-axis, right? So if it was a line following across the x-axis, then the rise or the slope is always going to be 0. It's not going up or down any, right? So it's 0. Now it has run, yeah, left and right, but it has no what? Rise. So that's 0 over some number, who cares? But 0 over anything always still makes 0, right? Okay. Now, the other special case, however, is a vertical line. A vertical line has rise, but what does it not have? Run. So if I have rise, and it doesn't matter what the rise is, but my run is 0, do you remember what happens if you have a denominator of 0? Is that good? No, that's never good. What happens? It's undefined. Okay? So, if you have a vertical line, vertical again just means straight up and down. Give me an example of something of a line that you know of that's straight up and down. The what axis? The y-axis. Okay? So a vertical line, the slope is always undefined. So if either of these cases there's no math to do, just look at the line and go, undefined. Okay? M is the letter that stands for slope or gradient. Remember, that's just another way of writing slope or gradient. And I'm going to write that more than I'm going to write anything else. But you can write out the word slope if you want to. Okay? So, what if I have this line that I just drew right there? Horizontal, so slope of 0. What about the y-axis? Vertical, so slope is undefined, right? You can't measure how much something is going up or down if it's straight up and down. It's going straight up and down all there is, or more than there is. You can't tell, right? You can't measure it. Okay? So there are those two special cases. Let's see. Here we go. So this is in your homework. We're going to do a couple of these together, though, just to get this. This is page 12. Thank you. Page 12 in your book. So calculate the gradients of these lines. So let's just look at A first. First of all, as I look at it going to the right, it's going what?
Positive.
Up. Yeah. So we know that this slope. Yeah. So we know that the slope is positive. You're fine. Okay. Yep. So hold on a minute. I pushed a button. Okay. So we know that the slope is positive, no matter what. Okay. Now, all I need to do is find 2 points on the line. My only criteria is that they have to be on where two lines intersect. So, on these, all of these, you're just going to use the ends. They were very weird about drawing these lines. They don't give you any choice. So don't always think it's the end of the lines. It's just the lines they drew. Okay? Yes?
Is the horizontal line always equal to 0?
The slope is always 0. Mm-hmm. Yeah. So I'm going to count from the bottom up. So up and then to the right. Okay. So that's up how many?
3, 2,
3. So that gives me a rise of 3. And then to the right, how many? 2.
We always have to say that it's negative or plus.
No, I just do it for effect, because I want y'all to see it. So my slope is 3 over 2. And you should leave it as 3 over 2. Don't change it to 1.5. Okay? All right. How about D? No math to do. Why? It's horizontal, so the slope is 0. Now notice I'm putting M equals. Yes, you do. You do as well.
Do you have to state on the thing that it's a positive or negative?
You don't have to if it's positive. You do have to if it's negative. I just always do, because what do y'all love more than life itself? Sign numbers. So I always do, just to reinforce it. Okay? Let's see. How about H?
Undefined.
Slope is undefined. There you go. And you can abbreviate it. Fine with that.
I have a quick question.
Yes, ma'am.
So if it would be like 1 over 5 or 2 over 1, do those both just equal the number that's not 1?
No, because if you have, one of them would. So if you had 1 over 5, that's just 1 over 5.
Okay.
Right? But if it was 5 over 1, you could just write 5.
Okay.
Because you know that it is a fraction. Slope is always a fraction. But if you write it as a whole number, that just means what's the denominator?
What if it's like
A 1.
1
So
over
you
2?
don't need to write it. Pardon? 4 over 2? Nope. If you end up with 4 over 2, that's 4 divided by 2, which is just plain old what? 2.
So we write 2.
Yes, so you just write 2.
Do we have to always simplify? Or only when it's...
You must simplify, if it will. Okay? All right, which one do you want to do next? We'll do one more. What letter you
Can we
want?
do E?
E? E is your favorite? Okay, fine. First of all, it's going down. What's that going to tell you?
Negative.
Slope is going to be negative, right? So your slope is going to be some negative number. So start here and go until we hit the next point, which on all of these, unfortunately, is the ends. I don't like it that they're doing that, because I don't want you to get the impression that it's always the end of the line. It's not, right? If these were real lines, then what they would be doing is they would be continuing forever in both directions, right? But they're just using line segments for these, but that's okay. All right. So from here to here, I need to go not up, but what? Down, and then to the right. So down how many? Down 3. And to the right how many? 4. And we've already got our negative there because we went down. It was really a negative 3 over a positive 4. But a negative 3 over a positive 4 makes the whole fraction turn into a negative. Okay. F? Okay. Oh, it's okay. Going down, so you go down and then to the right. So that means it's going to be negative. So 1, 2, 3, 4, 5, right? Down 5. And then to the right 2. Make sure you say right or left because you'll know what sign. And negative 5 over 2 is negative 5 over 2. Just makes the whole fraction.
And then you don't do the whole...
No, don't convert it. That's the answer.
No.
Don't change it to 2.5. You don't want to. You can use improper fractions. No mixed numerals.
I'm pretty sure it's gradient F, not gradient B.
Oh, sorry.
So if it's 5 or 2 something, then you can't simplify it. You just leave it as though.
Okay. I just used the first line that was available for me there. Here. Yeah, you don't convert them. So there's a difference between reducing. So 6 over 8 turns into 3/4, right? But 4 over 3 turns into 1 1/3. This is reducing or simplifying. This is converting. They are not the same thing. This you would do if it was a word problem. This you do when? Always. Okay? But if you're just wanting the slope, you can just leave it as an improper fraction. That's perfectly fine. So do not convert them to mixed numerals. It's very rare in math that you would convert a number to a mixed numeral. Okay? Alrighty, let's see what else is on this page. Nothing else on this page. Good. So let's move to the next page. Okay. Uh-oh. Oh, well. You'll survive. So, draw line segments to show these gradients. Now, they've given you the grid paper at the bottom to do it. So you need to just draw lines that represent those gradients. Okay, line segments just means start and stop at the point. Make sure you label them. So A gives us a slope of 1/2, right? So if we're going to do a slope of 1/2. So that just means go up how many? And to the right how many? And so there's your line.
What about H?
What about H? Okay, what's the slope for H?
1 and 1/2 negative.
Negative 1.5? Oh, we don't like that. We have to change it to negative 3/2.
Well,
Now, it doesn't matter. It doesn't matter if you have a negative in front of a fraction. When you're drawing the picture, that negative has to go somewhere. And it can go either in the top or the bottom. But wait, guys, listen. If I have negative 2/3, is that the same as negative 2 over negative 3? No, that's both of them negative, which makes the whole thing positive. So you can put the negative in the top or the bottom. Now, here's my advice to you that will make your life easier for the rest of your mathematics career. Always put the negative in the numerator. Because if you do, then you're going to be safe from a lot of pitfalls later in your algebra. Okay? So, if you have negative 2/3, where should that negative go? Up at the top of the 2. Just always do it. Trust me. It will hurt you later if you don't. Okay? All right. One place I don't want you to be flexible. So this is what? Which letter is this? This is F, A, M, H. H. Okay. I don't want to write down the wrong one. So it's negative 2. So we know we're going down. So let's start there. Go down 2. And then, I'm sorry. That's my actual number. That's one I made up. So go down how many? 3. Right? So start here and go 3 down. And then what? To the right, 2. So down 3, to the right 2. You just start it at any point that you want. Well, 1.5. Remember, it's 2 times 1 plus 1. So multiply that and then add it there. 2 times 1 is 2 plus 1. That gives you 3/2. You can look back at it if you need to look at how to convert those. So, all right. How about J?
yeah.
And then you put it to the 1.
So this is like 2/2. Z? I don't want to.
Wait, I'm sorry. Can you repeat the steps how you got 3 and 2, negative 3?
So, pages 12 and 13 for your homework. And that's it. Until next time.